So we are going to evaluate some of these functions. We are going to evaluate some of these functions. So let's just use the same number, or do you want us to use a different expression? Okay, let me use a different expression. And I will now write the way that the question typically comes. So let me write so you can say example 5. So it will say something like this. Given that f of x is equal to 2x plus 1 and g of x is equal to x squared plus 2x minus 1. So find f plus g of x, then evaluate the sum when x is 3. Then evaluate the sum when x is 3. It could be any other number. So this is typically how the question is framed. And Nerisha, that's where, after doing the sum, that's when we substitute a number.
Okay.
Yes. So now, so I'll give everybody 1 minute to do the sum, and then we will do the evaluate together. Everybody, so do it in your own paper. 1 minute. You have 1 minute from now to do the sum. Do the sum of f of x and g of x. So, and then tell me the result. After 1 minute, we will just substitute the number and do it together. Oh yeah, go. Okay, so what's the solution, ladies and gentlemen?
I got x squared.
Hold on. Let me write this. I want everybody to cultivate this habit of writing solution before you start anything. Writing solution, because we are solution providers. That's what mathematics is all about. You're solving problem all the time. And yes, so now let's go. So f of x plus g of x is going to be what? I'm listening.
I got 2x plus 4x. No,
okay, why not start with the one that says x squared?
Yeah, x squared.
X squared
plus 4x.
Plus 4x.
Plus 2. I don't know if is that correct.
Is that, remember, this is 1 here. This one is -1.
Oh, negative. Oh,
did you deal with it as +1 or -1?
Oh, I thought it was a positive.
I mean, what do you want? Yeah, we can make it positive. It's up to you. What do you want? Let's use 1.
I could change it.
Positive or negative?
I could change it to a negative.
Okay, so everybody change it to negative. It's -1. Okay, so reevaluate your answer. -1 plus 1 is what?
0.
0. So you can write 0 or you ignore it. Okay, the choice is yours. Then it says evaluate the sum when x is 3. So all you need to do is, you see, this is your sum. Is
you just plug in 3.
Exactly. Sum is x squared plus 4x. So, and the sum now is 3, and then you substitute 3 into the wherever you see x. So you are going to have 3 squared plus 4 3. Okay, so that's going to give us 3 squared is
9.
9 plus 3 times 4 is 12. So your function sum when it is 3 is going to be 21. So you can also write it as f plus g of x or of 3. Actually, I'm sorry. Let me rewrite it in a proper way. So this can be written as f plus g 3. At this point, you can write it as f plus g x is equal to So this is how to do some of this stuff. This is how to do some of this stuff. Okay? Do you want us to do one more example before I give you something to do? The time now is almost 9:20 and the class ends in about 25 minutes. Okay, so do you want subtraction or multiplication?
Wait, Mr. Cable, so we're not going to do division today?
We're not going to do the division today until we do long division as a topic and also until we do partial fraction as a topic.
Okay.
These two topics we have to do. Especially the long division, you can make reference to your algebra 2. The partial sum, I don't know if it's in algebra 2. That we have to do. Because with this type of a thing, that's how you are going to, what you are going to use to solve it. We can use next class to do it. I don't mind doing long division next class, and that's actually the right time to do it, so that we can do long division and partial fraction next class.
I say we do it next class so that we can just get like over this entire like topic as a whole. Like,
okay, that's fine with me. We will do it next class. I just don't want whatever we are doing today to be confused with anything. I don't want any. I want you to understand how to combine these things. Once you're able to master that, the other things will be added onto it, on top of it. So next class, long division and partial fraction. Okay?
Mr. Ukebu,
Yes?
are you still taking the attendance?
Yes, I will.
Okay.
Just type in your name on the chat section. That's going to do it.
Okay.
Everybody, please type in your name on the chat section. I will use that to do the attendance. Okay, so now time now is 9:21. So let me find something you can quickly do. Okay, one more example you said. So do you want multiplication or difference?
Can you repeat that, Mr. Cable?
Do you want us to do an example regarding multiplication, or do you want us to do an example regarding difference?
Multiplication, we could do multiplication. It's more easier because we did it before, but if you want to change it, we could do the subtraction because we never really did it. We never did a question by ourselves with
multiplication.
We did it with multiplication a lot of times.
Okay, so we can say a question could be of this form. A question can be of this form. The area, okay, there you go. Determine the area of a rectangular lawn shown below. So a rectangular lawn could be your football field. It could be your table. It could be anything. Bottom line, it is rectangular.
Lawn, lawn, Mr. Cable?
Lawn, how do you spell it?
L-A-W-N?
That's what I did.
Okay.
Okay, doesn't it appear? So that's L-A-W-N, yes. Okay, so now let's give a number like this. Let's provide a number and say x plus 2. And then we have another number that says x cubed minus 3x squared. So determine the area of a rectangular lawn shown below. Then find, this is part A, find the value if x is 4. Find the value if x is 4. Okay? So solution. So go ahead and start doing it. Go ahead. Solution. So what is area? What's the formula for area?
Length times width.
Okay. So basically what they are telling you based on what we have on the board right now, what they are telling us is that there are two functions right here. One of it is f of x, and the other one of it is g of x. You don't have to really define all these things for you. You can, based on the, you can define it by yourself, and you can alternate it. So it doesn't really, the solution is going to be the same anyway. So what that means, formula for area is going to be what? Length times what? Width. Is that not correct? So now our length could be x cubed plus 3x squared. and our width could be x plus 2. Okay? So now we use distributive property. So we say,
Mr. Cable,
yes.
on the rectangle, it says minus 3x squared.
Oh, okay. Yeah, thank you. Thank you. Yes, thank you. At least somebody is paying attention. Yes, so thank you. So now let's use distributive property quickly, everybody. So the first one, x times x cube is what?
You already said that.
X times x cube is what?
X to the
X to the power of 4. X raised to power 4. Then minus 3x squared times x is what?
negative 3x cubed.
Negative 3x cubed. So we are done with that. Then we now use 2. 2 times x cubed is what?
2 times x cubed.
Yes. It's going to be
2x
cubed. Then minus 2 times 3x squared is going to be 6x squared. 6x squared. So this is the area in terms of x. And then the question says again, find area when x is 4. Find the area when x is 4.
Should we not combine like terms first, Mr. Cable?
There are like terms to combine? Yes, so we can combine it. We can combine it. Even if you don't combine it, as long as you make your substitution correct, it's going to give you the same solution. So we can combine it to have negative x raised to power cube minus 6x squared. And then this is x raised to power 4. So yes, you can combine like terms. Also, even if you don't combine it, as long as your substitution is correct, it's going to give you the same result. You got it? So now let's see what it's going to give us. And let's see if we have a solution, because our problem could be wrong. So, but let's see, let's go for it. So we have 4 raised to power 4, right? Minus 4 raised to power what? 4 raised to power 3 minus 6, 4 raised to power what?
2.
2. So let's evaluate. So what is 4 raised to power 4?
256.
256. What is 4 raised to power 3?
64.
What? 64 you said?
Yes.
Okay.
Sir.
And then what is 4 raised to power 2 is 16. 16 times 2 is 6 is what? 16 times 6 is what? 6 times 6 is 6, 36, carry 3.
96.
96 minus 96. Okay, so do all the computation. AX, so do all the computation. 256 minus 64 minus 96 gives us what?
I got
224.
96.
200 100 and something?
No, it's 96.
I missed the thing.
Is it 96?
Yes, sir.
Okay, 96 is the solution. So by the way, if on the other hand we have a negative number here, can you in real life have a lawn that is negative in number? For example, your football field, can it be, when you measure the length and the width, can you have a negative number?
No.
No. So that means our problem was wrong. That's what it means. Your computation can be correct, and then you get a result, and then that the problem could also be wrong. So there are certain numbers that by the time we put in it here, we put certain number here. If we just put any number that is more than I don't know, but there are certain number that we can substitute as x, and then it will not have a real result.
Okay, so from the beginning, it was already wrong because you already had a negative number. This statement was already false because you already had a negative number, like negative 3x squared. You say
no, that doesn't make it wrong, because that's just an expression. That doesn't make it wrong, because that's just an expression. An expression can be a number. If for example, let me experiment something now and tell you exactly what I mean. Let's work on this one. Let's work on this. This is actually a good exercise now. Let's work on this. let's try various values of x. Okay, so we have f of 1 will give us 1 cube minus 3 1 squared. What is that? 1 cube is 1. 1 squared is 1 times 1. So you have minus 3. So you're going to get negative 2. Now, the question now is, can you get a length of a number that is negative 2?
No.
Okay.
Yeah,
Now, let's see. Let's try our negative 2 now and see what the result of the area is going to be. So let's use negative 2 now. Let's say area. Let's see area when x is negative 2. So we are going to use this formula now. We are going to use this formula, this one, because that's our real area, right? So now let's substitute negative 2. We are going to have negative 2 raised to power 4 minus bracket negative 2 raised to power 3 minus bracket what? Not bracket now, 6 bracket negative 2 raised to power 2. So now let's evaluate. Nerisha, that is what you were asking us to do, and that's what we are doing. So negative 2 raised to power 4 is going to give us what? 2 times 2 times 2 into is 16. This should give us 16. Then this is going to give us what? This one will give us negative 8.
I thought it was going to be positive because it's a negative. And
this is going to give us negative 8. This one, because you are going to have negative 2 times negative 2 times negative 2. So this is going to give us positive 4 times negative 2. So this will be negative bracket negative 8. Then minus, this is going to give us 6 positive 4. Positive 4. So in that case, we are going to have 16. Negative times negative is positive. So plus what? Plus 8. Then minus 6 times 4 is what? 24. Thank you. And then 16 plus 8 is also 24, right? 24 minus 24 gives us 0. So in the real sense, the value of x cannot be equal to negative 2. Because if the value of x is negative 2, the whole of this length will turn to 0. And 0 times any number is going to give you 0. So in the real sense of it, you cannot have a football field whose area is 0. What that means is that football field does not exist anywhere. Any question?
No, sir.
All right. So that's where we are right now. That's where we are right now. So some values are possible. Some values are possible results. Some values are not. That's just the bottom line in all this stuff. Just to conclude this, find a value when x is 3 and upload your result. Task: find the area of the lawn when x is 3. So you can say, is it a possible real value for area of lawn, of rectangular lawn?